Hello, everyone. Welcome to today's Android Office Hours. Today we have, as always, a packed agenda for you. We're diving into a couple of important ecosystem updates from June 2026. We will look at the rollout of the multi-store developer verification rules and APIs and expanded billing options throughout the ecosystem. We'll examine these global shifts directly, how these shifts directly impact and empower our local developers in across sub-Saharan Africa and Middle East and North Africa and Turkey. So let's really make sure that we fully prepare to leverage these new updates to the ecosystem. As always, we will start with a 5 minute ecosystem update run, and then we will be joined later in the presentation by none other than Brian, also known as Mambo, who is a GD out of Kenya. He will give us a presentation on testing on Android and how to harden your apps for um, sort of challenging regions like SSA and MENAT. And then after that, we will go through a lot of Q&A. A number of you sent over questions that we will answer throughout the Q&A. Without further ado, let me go through the ecosystem updates for you. Today we have mainly two of them, really. Um, First, we'll start with the security, trust, and app distribution. As you know, to protect users globally, Android is introducing standardized developer identity verification protocols across major app marketplaces. This policy is being driven by a massive multi-store coalition. Security checks are standardizing across 7 major stores. Most importantly, for a region like Sub-Saharan Africa and the MENAT, Transion, Palm Store, and the Google Play Store. Transion Palm Store is a key partner in this alliance. Because transient for devices represents a lion's share of smartphone in this region, our local developers must prepare. And so verification is no longer just a Google Play requirement; it's a cross ecosystem necessity for distributing apps on all of these stores. Now we do know that there are cases where young developers or hobbies might not have formal entities and all of that, and to prevent locking out that kind of talent, we're also launching the hobbies, a path for hobbyists and students to still distribute apps in a for limited distribution accounts. These accounts are designed specifically for students and hobbyists. They will bypass the intensive ID requirements and a registration fee, so it will be free. So allowing students and hobbies to still share apps across up to 20 devices. It is also the perfect sandbox for regional university tech hubs, for example. Now, beyond that, let's discuss money. Google Play is also rolling out alternative billing pathways by fundamentally separating platform service fee from payment transaction fees. This fee separation is a massive win for a startup unit economics. This new model, the core platform service fee for your first $1 million in annual revenue is just 10%. And if you utilize Google's billing, there is an additional 5% processing fee. However, if you choose to redirect your users to an external billing link or use an alternative checkout, like M-Pesa, for example, in East Africa, or um, um, Madapay in Saudi Arabia, for example, you can bypass that fee entirely. This gives you a lot more control and flexibility over your margins. I want you to take a note of three key compliance dates. While pilot testing and early rollouts are happening throughout late 2020, in market like Southeast Asia and Brazil, full global expansion and mandatory registration will take effect by September 30th, 2027. I highly advise our developer partners, our developers in these regions to start aligning their verification details and explore alternative regional billing pathways now rather than waiting for the 2027 deadline. And before we wrap up this segment, I want to highlight also some incredible community events that are happening throughout SSA and MENAT in the next couple of weeks. We'll start with the during the week of July 3rd and 4th. We have Build with AI in Bursa, Turkey. On July 4th, we'll have two events: Build AI and IO Extended combined sessions in Kaduna and Jalingo in Nigeria. And then moving into next week on July 11, you can catch Google I/O Extended in Jinja in Uganda, and another Build with AI workshop in Lokoja, Nigeria. These sessions are perfectly physical environment to connect with local peers, local thinkers like you, and get hands-on experience with all our new offerings. Now, to the meat of today's agenda, I'm going to bring in Mambo Odhiambo, also known as Mambo. He will give us a technical deep dive on testing and especially why it's super important for regions like SSA and MENAT. Mambo, welcome to the show.
Thank you very much, Chris. Hello, everyone. Nice to be here. Um, so
Bef-
today,
before we actually get in, Mambo, can you tell the
yes,
people a little bit about you, what you do, and your journey into Android development?
yeah. So interestingly, I got into engineering because my friend we were just on the streets walking, and my friend told me that people were actually building apps like Instagram and WhatsApp. And I had no clue, no idea what engineering was. So I just started Googling around and finding out like how do people create mobile applications. I stumbled on Udacity at that time, uh, and they were offering a Google Nano degree. So I just
Wow.
started working through it, and uh, after
Was that
going
was
through
that
it,
the Android Nano degree,
yes,
or
it
is
was the
it
Android Nano degree.
okay? Nice, nice.
I was a school bus driver then, like,
Wow.
and just reading on my part time. Started building applications on the side, just trying things out. applied for an internship opportunity and I got it. And I was like, oh, people are actually paid to do this work.
Awesome.
Started looking for a community around to figure out how to like become a better engineer.
Mhm.
Stumbled on Android 254. Thank you so much for my mentors who guided me through all this part. And yeah, that's how technically I became an Android engineer.
And you are also a Google Developer Expert on Android. You are one of
Yes.
three in the whole of Sub-Saharan Africa.
Yes. We are
Uh,
just
how long?
three Android engineers.
How long have you been a GD?
Going on 2 years plus, I think.
Okay,
Yeah, 2 years
awesome,
plus.
awesome. Great to hear that. So, with that, let me get out of the way and give way to the presentation. Thanks, Mambo.
Thank you. Thank you, Chris. Um, So today we want to speak a little bit more about building robust applications and essentially focusing on the testing bit of robust applications. As I said, my name is Brian Odhiambo, a Google for Startups Africa mentor and Google developer expert for Android. So one thing we should know going forward is testability is an architectural property. It's not just something put on the side, an exception. It is an architectural property that we should try to emulate in as much in our processes as possible. In ACCA region, the key assumptions for normally most of the devices is network is the exception. Not everybody has access to the network, or if they do have, it's mostly not as fast as we'd expect. Also, the mobile devices are resource constrained, so they're not as fast as the developer um, writing the code. So we'd like to also plug in that. And also, due to this, there are a lot of vulnerable code paths with these two exceptions, right? So today we want to focus a little bit more on principles of testing that we can use throughout our journey so as to make our application as robust as possible. Better yet, all these principles can be converted to skills that you can use with your AI agent so that it can follow through each and every individual principle to ensure the whole application is perfectly tested. These principles are covering the failure paths first, having small and independent tests, testing the behavior and not the implementation, and ensuring we control everything that varies, and finally, proving the slice from end to end. Now, for the first part, we need to cover the failure part first. Normally, what we do is we jump quickly to the success part. For example, on the left, we have um, a function that fetches from a backend server. And the first thing we do is we write the function, and most technically, some of the time, we ensure that we write maybe a test for the success bar. But 90% of the time, or major percent of the time, we find that network is not available, right? So us focusing on the failure part first helps us technically to plug in the holes and ensuring everything that is supposed to happen wrongly has already been taken care of before what happens rightly. So as you can see on the left, we're just returning one single data transfer object from class, but on the right after, we are returning an outcome that can be of a failure or a success. So it might return that user DTO or any failure that we can slowly assert as we go. And having this, we have something like a mock engine or a fake engine that we can use to inject our current responses, either a failure or a success. And with this, we can test as we go. So if we do not cover this, the current cost for the user when we do not cover this is the user might have a drop connection and the app crashes because we have not covered the failing uh, flow. Also, when a backend field is renamed, it also fails. because we have not covered that also. When the user is also offline, we have not covered also. All this amounting to a very bad user experience. And for the team, now we are constrained with just testing with a lifesaver and nothing else. Testing becomes extremely slow because we have to plug it into a server. We have to open the application, ensure that the server is up and running, returning the same response. All this can be mitigated with a few simple tips and tricks. One is adding a mock engine to generate the failures, listing your failures as long as possible, and then making sure all our tests are named explicitly by the scenario so that we know exactly what is failing instead of trying to second guess. So that is the first principle. Cover the failure path first and try as much as possible to cover every failure scenario. Our second would be to write very small and independent tests. So I know we're normally of the opinion sometimes it's wondering to rule them all, and this might become a very huge test that want to insert, update, delete as you're going. But sometimes it's best to just write one test, single responsibility, for us to know exactly what the test is supposed to do, and when it fails, why it has failed. For example, on the left before, we might write a test that inserts, updates, and deletes, right? So three things in one. After, we might try and make it extremely smaller and more independent. So maybe just one insert to make sure it inserts or upserts correctly. Um, and then a replace to make sure that, wait, what you've inserted, we can actually update it correctly. And the last would be to delete, to test if I insert something, the delete function works as intended. Case in point is we need to do this so that if anything fails, we know exactly what fails. If we have one huge test and it fails, we might not know exactly why or what has failed. And this translates back to the user. Uh, Having a huge test may be extremely flaky. A whole test suite we have shipped. Yes, we have shipped, but it's extremely flaky. Sometimes it works, sometimes it doesn't work. Um, Sometimes users are left with a blank screen and don't understand, okay, but I've just inserted this, what is happening? Now, for the engineering team, the ones who are developing, everything works on our local machine. Everything is green. But then again, if we ship, everything fails. And mega test becomes ambiguous, and the fail even becomes even worse because we're not exactly particular to what exactly failed. So a good trick for this would be, for example, if you're testing a room database, is just one fresh in-room DB per test so that we have clear data, one behavior at a time. We should not chain as much behaviors as possible. And sometimes we do not want to use a real device. So running something, using like RoboElectric to run this test on GVM would save us so much time, even in CI. The third principle is to test behavior and not implementation. And this is something that we might do subconsciously and test, wait, did this function, was this function called? Or was this function called? Or this or that? But remember, we might call this function with maybe the wrong data. And we are testing if only the function was called. This might lead to a very long test cases, right? So a good thing would be to test the value that is actually returned. What the user gets is what we need to be testing to make sure that, one, yes, the function was called in this case, but is it returning the right data? For example, on the left, we can see we're just testing, wait, have we verified if the fetch user has been called? But on the right, we are trying to check, okay, have we essentially made sure that the fetch user, we have fetched the current user and it has been saved? Now, this also translates back to the same users and teams. If we write a fragile test. The user is the one who pays at the end. Maybe they save and their profile vanishes and the data is not shown and they don't know, okay, what is going on, but as we tested if the function was called. And maybe we might merge bugs that can accidentally wipe off the cache when someone is offline. So these are things that the user pays at the end. For us engineers, the test would break on every single refactor. We try and refactor and it breaks. Now we have to rename the function, or we have to try other tests that to make sure that everything works. This now just leaves to even more frustrated developers who essentially would now start deleting the tests that are supposed to help them. A good metric would be to assert the outcome of the function. This would be a very nice metric if we are testing, right? And we should combine this test with either a room database, a real actual room database, and a fake remote API to make sure that everything is being tested, the underlying layer and also the current layer that we are currently on. Now, the fourth principle is to control what varies. So we might be running a test on a coroutine, and we have instead of injecting our own dispatcher, we explicitly label the dispatcher. And in this case, every single function test that we are going to run, we will have to um, pause so that we get the result. And then after that, we assert for every single function. Our functions can be even longer and takes much longer time even in the CI. Our builds are racking up. Now, we want to make this as simple as possible. The first thing would be to inject a dispatcher so that in any case, we have control of what this time that we are supposed to wait that is valid. So in the left, we say, for example, before we're just calling the dispatchers.io directly, but now after injecting our own dispatcher, we can essentially just provide that dispatcher and let it run, and we will know we don't have to wait until a certain point because it currently runs on virtual time, and the value and the result will be returned immediately. If this also translates back to the user. Now, if the user presses a button twice or a function is being run twice, this might lead to race conditions and maybe stale data, or the data would be updated or removed without them knowing. And also another thing would be a user might press something and it just takes on loading and they don't know exactly what is going on. Maybe there's a retry mechanism that retrying and still it does not work, and they are currently confused what is going on, which they file a bug and we're not sure. So for us developers, what might happen again is we might start ignoring tests, going by the belief, for example, your model cannot be tested, it can only be tested by emulators and things like this, which might not lead to a very robust application at the end of the day. So a few tips would be one, to inject a coroutine dispatcher, use a main dispatcher rule and things like run testing to make your test shorter and more effective, and use libraries like Turbine to assert every state emission to make sure that the whole process that the user should go through is actually going through as you intended. Now, our last principle would be to prove that slice end to end. And this case would be like now proving if what we have been doing from the network layer till the UI layer, everything is working as intended. So this would be now to giving your composables the current view model with all the fix, and with all this ensuring that from if a user clicks in any button, or if they're offline, there's a banner, or if the um, the request fails, there's a retry mechanism. If we do not assert this, prove that, okay, we have developed from network till the UI layer and everything is not correct, what happens is it goes back to the user. The user, all the current things that we have been trying to ensure that do not happen, it happens. The user maybe uh, flags on an empty blank screen and they are waiting, don't exactly know what is going to happen. The key user journey of how they need to be clicking till the end result is also not being asserted. And for the team, now these bugs that we have been trying to ensure that they do not go into production, slowly slip in to production. You have a call on Saturday or on a Friday afternoon being told, this is not working, you have just broken this or that. Other things would be now with more cryptic failures. We are not sure, 100% sure what is failing and why, leading to a very slow debugging, right? So a few tips and tricks would be to assert exactly what they need to see on the screen, ensure that it is visible to to the user. Name our test exactly by the scenario we are trying to test, right? So that if it fails, we know exactly the scenario and why. And we need to ensure that the loop is always closed. If it's a it's a fetch request, the user can retry. We can actually test that retry and ensure that it works as we intended for it to work. Okay. Um, in conclusion, we have gone through all the current layers and seen how we can use these principles in order to make sure our application is as robust as possible. The first one was to cover the failure part first, and this we were doing in the network layer because 90% of the time, or majorly percent of the time, people who do not have access to network, tend to um, we tend to test only the success part and leaving the failure parts. So a good metric would be to test also the failure parts. Second, we went to the room DB and ensuring that our tests are small and independent. We don't want to put mega or very big tests that have very many steps, and when they fail, we are not sure what has failed. The third one would be to test the behavior, not the implementation details. We don't want to assert that a function has been called at some time. We want to assert the outcome that needs to come back. We want to make sure that it is the result that we want. Um, some others were control. The fourth one was control what varies, and this was one was with the dispatcher because we want to use the virtual time. We don't want our tests to run as long as possible. So we want to control this, and this was injecting the dispatcher. And the last one was to prove the entire slice end to end. Now that we have made sure that all the other layers are working, we want to make sure that every single flow that we have added works from end to end. Yeah. Now, the key takeaway for this, for the robustness, why we need to build robust application is because we want to ship apps with confidence. We want to make sure that when we are shipping an app on a Friday, 100% sure maybe there might be no refactors or very minimal refactors on a Monday, right? And you have peace of mind during during the weekend. And if a test is extremely hard, what we want to do is fix the underlying application design to make the test easier. We don't want to blame like, oh no, it's this framework does not allow this. This is not testable. This we cannot do this. No, we want to make sure that we fix the underlying application design and then make it easy for us to test in future. Yeah, that's it for me. And that's the current five principles. Thank you very much.
Thank you very much, Mambo, for that insightful presentation. We will now move to the Q&A part. of our office hours today, and we'll start with some of the questions you guys have sent in. I'll take the first couple, and then we'll rotate through the rest, Mambo and I. So first one here. In regional markets where network drops and slow connections are the common case, why is it highly recommended to test our network failure path before writing tests for successful responses? Mambo was just talking about that now. I think in regions like SSA and MENAT, I would say the network is often the exception because we mostly design for offline first, and it's not a permanent rule. So with that in mind, testing the happy path first creates a certain false sense of stability, whereas in production, um, unhandled edge case network responses would frequently lead to um, in app stalls or crashes, ANRs, and even like and so on, right? Like you have a pretty high ANR rate. And so by designing tests for timeouts, connection drops, API mutations, you sort of not fully guarantee, but you have a good coverage that fallback mechanism are functional. Your the fallback mechanism that you built into your logic are functional before shipping to your users. Any anything you want to add to that, Mambo?
No, 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 no.
Yeah. Okay. Okay. We can go to the next one. So, um, an application crash can waste a user's mobile data on re-download. How exactly does moving away from direct client calls to a typed outcome wrapper safeguard the app on dropped connection? This is a really good one also. I generally personally, and this is a personal thing, consider like direct HTTP calls very dangerous, in the sense that they are likely to throw a network exception like IO exception or like timeout exception. And so um, if left unhandled, and this ties to the first question we just talked about, and this exception can just crash your apps. And so like if you introduce something like a typed outcome wrapper, that matches a response to explicit subclasses like success, failure, or failure offline, failure timeout, whatever it is. That it intercepts exception directly within the network layer. And this in turns turns like a unpredictable runtime system failures, like these exceptions, into more predictable data states that you can manage more easily, and prevent those crashes that we definitely do not want, especially in our regions, to prevent churn of your users. Next question. Can you demonstrate how engineering teams can use Cater's mock engine as a reliable failure generator to simulate timeouts and offline exceptions without relying on a live staging server. Let me reread that. Sorry. Can you demonstrate how engineering teams can use Cater's mock engine as a reliable failure generator to simulate timeouts and offline exceptions without relying on a live staging server? Mambo, I'll throw
Yeah.
that to you.
Yeah. So every single network client offers a mock engine that essentially what it does, it lets you dictate the behavior of maybe an endpoint or an API, right? So suppose you want to mock or fake how timeout would be. So your mock engine would be your best bet because inside the mock engine, you can just delay for, let's say, more than the limit that you have set in your application. And it should delay to that point, and you should catch a failure or an error. If not, it means most probably it's not working as intended, and we can now try and ensure that the timeout is adhered to as much as possible. This is not only for timeouts, this is even for malformed responses. You can inject your JSON immediately or read it from a file and assert that in any case, if the JSON is malformed or there are not proper fields, the crash is caught and it is not just propagated and the application crashes. Yeah. So that's how you can just that is just some of the ways you can use Kato's mock engines to simulate timeouts offline and things like that.
Are you trying to say there that with Kether mock engine, um, we we are designing for sort of more deterministic outcomes?
Yes, yes. So
Okay.
as I said, like you can use it as your go-to to simulate what
Hmm.
the API can give you. So instead of relying on an actual API, so you have to connect to a server every single time, you can use the mock engine as your server for it to return the responses you would want and see how it behaves. So it's more deterministic in this case.
Yeah, yeah. I think the one thing I'll add to that, and I agree with I wholeheartedly agree with that last part. I think live servers can, um, if designed well, they works, but like they can be also very slow, flaky, and hard to
Yeah,
to manipulate. So, yeah.
yeah.
All right, let's move to the next question. How can we let's see, let's put it on the screen. Yeah, how can we safely test our network response layers against unexpected schema variations caused by fragmented regional integration, such as local financial gateways and stablecoin payment platforms? That's a really good question as well. Do you want to take a stab at it, Mambo, and I'll
Yeah.
add color later. Yeah.
Testing network responses layer against unexpected schema variations. Hmm. This is caused by fragmented regional integrations. Ooh, all right. That's interesting. So every single region having its own schema, like like how we discussed with the Cater mock engine, you can try and pass different schema variations to your mock engine and then see how your applications handles them, or if your parsers actually knows how to switch between one or the other. So you are making the non-deterministic changes to a more deterministic while trying to put every not necessarily every schema variation, but if your application can actually change to the schema changes, to the variations in this case.
Cool.
Chris, you want to add something?
Yeah. I think you cover it mostly. I don't have a whole lot of color to add there. Um, we can move to the next one. Lean engineering startups in our regions often deal with strict resource constraint. That's true. How does running room database tests on the JVM using RoboElectric help solve this challenge? Great question.
Yeah, very good question. So the keyword is lean engineering startups. Yes, you do not want to buy compute somewhere else for money that is not easily accessible. So you don't want to start every single device, every single room database test, for example, that requires context and an Android reference for every single time you want to run a test. So in essence, RoboElectric just helps you run um, your room database tests in the JVM environment instead of an actual Android emulator device because they tend to be more expensive than the normal JVM. So reduces the cost, makes the tests extremely faster, saves on compute minutes.
Yeah, it just doesn't reduce the cost. I think um, in if I take the example of SSA, for example, one of the feedback I've really gotten a lot traveling through the continent and talking to developers is that the equipment a lot of developers work with in the first place also um, is sort of resource constraint itself, right? And
Yeah.
so spinning up physical like emulator on top of everything that's running on your machine is a heavy tax on the machines themselves, on the hardware, and also if even if you go the route of actual physical hardware instead of emulators, that also is a cost piece of it, right? So JVM via RoboElectrics give you sort of an environment that still mimics the true Android platform architecture directly, but without the cost and or the tax on your own machine or your lean engineering team, like the questions said in the beginning. Anything else to add to that, Mambo?
No, no, you
No.
cover that
Okay.
perfectly.
Okay. Cool. I think we can move to the next question. To eliminate the frustrating green locally, red in CI syndrome, what are the practical steps for isolating database states and ensuring a fresh in memory database instance per test?
Mm. It's the green locally, red in CI. Um, so in any test, for your test, you normally have a startup function and a tear down function. So you can actually just set up the database every single time so that you know for a fact, like it is fresh data. So if maybe the previous test added something and the next test is trying to assert that the database is empty, and it tends to maybe sometimes passes, it fails, it tends to be flaky. It's most probably we're not setting a fresh database each and every time we are starting a test, right?
Yeah, I think also like if you share a global database property across, say, multiple execution, contest, for example, I
Mhm.
think that introduces like a an ordering dependency, and maybe even like a pollution on the schema. Um, and so in my mind, building so like that for example, that may cause a test to pass when run a standalone, but then that may fail under like a multi-threaded CI for environment, for example, right? So I think the in those cases the solution is to perhaps mandate and mandate like absolute database state isolation, and building tests that verify um, exactly one distant behavior or query mutation at a time. And I think with that you can you can manage it a little bit better, because again, if you are testing locally, you are in most instances testing in a standalone fashion, versus in the CI environment that can be multi-threaded, for example.
Well said.
The next question: how does switching to outcome assertions help ensure that we test actual repository behavior rather than mock implementation data? I think this goes to the earlier question, no, Mambo?
Yeah, yeah,
Yeah.
yeah, it does.
Do you want to take a stab at it?
Um, so in this case, when you're testing the outcome of the result of the test, you're making sure that the result is exactly what you are requiring. So I can test if maybe let's say the execution was done, but that does not mean that the value that I'm supposed to receive is accurate. So we're going to the next step of saying we want to ensure that if given this value, I will need it to return this. Exactly. And if that does not work, it means the application does not work or the repository does not work as I intend. And that's the overall difference. So with the other one, you might just check, oh, wait, was this called? Okay, good, let's continue. But someone passes maybe data that is not supposed to be, and then you are certain if that is true, and you continue. It comes to production, everything is not working as intended. Why? Because we did not test the outcome. We did not make sure that the outcome was what was needed. So the outcome is very important for every single test.
Yeah, I completely agree. I think mock verification systems, um, I think they check simply whether like an internal structural function was executed, like you said during the presentation, right? And
Yeah.
that locks really your test closely to the current or the layout of your internal code base. Um, say someone modifies internal implementation safely. These tests will fail in an ambiguous manner, even if the app still behavior still remains like if the app still behave the same.
Yeah.
So I think that's where your recommendation of um, uh, switching from sort of just testing um, whether just a function is executed versus the outcome is the outcome assertion is actually what we get. I think during the presentation you made a really good example or phrase is like, what does the user get? I think it's as simple
Yeah.
as that,
Yeah.
right? What does the user get? And if you can test for that rather than did my function execute properly, or that will help a lot. Yeah.
It's a common thing that we see in SSA, that we tend to look at the implementation and not look at the user. So every single time, it's what is the cost of not testing this to the user? Because yes, maybe it might work at your current point in time, but to the user themselves, what is the cost of not testing this part?
Mm, yeah. Cool. Um, Next question. Why is it considered oh, actually, why is it considered an engineering best practice to ban the use of generic matchers like verify any in data layer tests? And how do we combine a real room database with a fake API instead? Um,
Oh,
I think I'll take a stab at that, and then you can come in, Mambo. Um, the I think the risk of using just generic matches, um, in my opinion, is to the risk is to hide data. Let's say there are corruptions, bugs, or oversights, and instead you validate in something that something happened, and even if um, complete it's, let's say, like, you introduce parameters that are erroneous to storage, um, we still just validating that something happened. By If you ban generic matchers tools and pair like an authentic in-room database instance, um, pair with a sort of a manually controlled, and in this case, predictable fake API implementation class, then you preserve sort of your real or realistic behavior. Um, um, so the fake API gives you more, I think, in my opinion, better control over the simulations. Like uh, you can simulate data layer drops, and room itself will serve as the true source of behavioral truth. For example, for checking um, persistent contracts. Um, I think the fake API route gives you that much more control, and also more confidence, rather than just generic matchers. What do you think, Mambo?
yeah, I concur. Sometimes we're talking about lean engineering teams. The time you're going to use to spend writing this test would be better off actually writing a test that tests the outcome of of what is
Go
supposed to return.
Going back to
And
outcomes, yeah.
yeah, like it
Hmm.
doesn't, you are verifying something that you're not sure if it's extremely robust at that point in time. You just say, okay, let's just leave everything to the wind because it was called. It
Mm,
doesn't work like that. And I've seen so many examples of this in things like someone does not want to test a work manager's execution per se. And sometimes I always say, like, a work manager in this case is just an executor. You can as easily as wrap what it's doing in a class and just test it um, very well so that you 100% know that it works instead of just saying, we have just left it at there. We are not sure. It was called, then that's it. Yeah.
yeah, yeah. Um, we can move to the next question. Hard-coded concurrency configuration frequently cause stock loading spinners or race conditions on slow entry-level devices. Yeah. How does explicit dependency injection of coroutine dispatchers fix this? I think you showed a great example during your uh, um, talk. Mambo, do you want to take this?
Yeah. So you automatically declare the dispatcher and that's it. Sometimes it's not. You try and run and write a test, and you see the test is failing after a few minutes, failing after a few minutes, and you start wondering what is happening, what is the problem, and most probably it's because your function has maybe a delay or something, and you're not in control of it at this point in time. So injecting a test dispatcher in short just gives you more control over the execution flow of any specific function inside any class that requires a concurrency configuration. It's you getting that control and ensuring that it runs within virtual time.
Yeah.
If it is going to wait for 5 minutes, it should not eventually wait for 5 minutes. That's the reason why we are using things like the test dispatchers and run tests so that we do not wait for 5 minutes. If one function will wait for 5 minutes and you have 20 functions, and 20 tests, if one test waits for 5 minutes and you have 20 tests, every single test is for 5 minutes, it means this is more compute time. So we the injection of coroutine dispatchers fix this uh, as um, as a process.
Yeah. Perfect. I think that actually ties in nicely to the next question about thread sleep. Um,
Oh,
yes, how do
there's a question.
run test and the Turban library allow teams to test these virtual time transitions instantly and accurately without using fragile thread dust sleeps?
Yeah,
I
and
think
this is
there
the
is.
thing. Yeah, go ahead,
Yeah,
please.
there is. Sorry, let me add a little bit of color to that question. They start with saying when verifying intricate asynchronous logic like network retry delay. I think that's an important part of that question. And you did talk about this also during your test. For me, it's just is the problem with something like thread dot sleep is just that it slows down your pipeline execution. That's it. And that can cause tests to just fail unpredictably. And the real benefit of run tests is the virtual time management clocks. So you don't have to wait, like Mambo just said, 5 minutes for every single test to run.
Yeah.
So yeah, you want to take a stab at this as well?
Yeah, so I actually do like the Turban library. It's not a recommendation, but it's what it does is what is actually really cool. The fact that it's a flow emission test, and sometimes you can go from, let's say, you have a loading screen to maybe an intermediate screen before you go to another screen. And maybe that intermediate state shows something on your screen. And we might tend to just test, wait, did we go to the end of the screen and everything works? And it didn't, right? And it might fail at this point in time. Also, something like updating states to avoid race conditions. Turbine can help you in this case to know like the flow of states that that you're currently emitting and if it's as accurate as you'd want it to be.
Awesome. Unfortunately, we have run out of time for the questions. So this was our last question that we'll answer today. I want to take a moment though to thank Mambo. Thank you so much for joining. I know there are a lot going on right now with Cloud Summit and GDE Summit.
Yeah.
So thank you for taking the time out of your busy schedule to join today. I really, really appreciate it. And for our audience, want to also say that this fourth session concludes the pilot phase of the Android office hours. These 2 week cadence that we've adopted so far was mostly during the um, pilot phase. We will evaluate the effectiveness of this series and hopefully bring them back in a monthly manner with more programming, better and quality programming, and more interesting hosts like Mambo today. Please do take a moment to give us feedback. Scan this QR code. It's helpful as we evaluate our programming for these 2 regions. Please take the time to give that feedback. It will help a lot. It will help us also figure out what sort of topic to cover going forward. Thank you so much for joining today's Android Office Hours, and we will see you next time. Thank you.
Thank you.